This is for period 1. I realized I forgot to do integrals of absolute values, so we're going to deal with that in 2 examples, okay? So let's say I have the integral of 2 plus the absolute value of x minus 3 dx, and I'm taking the integral of this from, let's just go -1 to 4. Okay, so if you look at this problem, keep in mind that an integral, you can actually break it up. So I'm going to break it up into -4, or -1 to 4 of 2 dx plus integral of -1 to 4 absolute value of x minus 3 dx. Okay, so the first part of this is very straightforward, because you can just integrate this. The integral of 2 is 2x, being evaluated from -1 to 4. So if I plug it in, it's going to be 2 times 4 minus 2 times -1, and we'll get some answer there. Let's spend our time focusing on the second part of this. Okay, so what does that look like? Keep in mind that absolute value, or integration, actually finds areas under curves. So if you look at absolute value of x minus 3, that is an absolute value graph that is just shifted over to 3. Okay, and what we're being asked to find in this case is we're being asked to find the area from -1 to 4. But notice I can kind of break it up as the area from -1 to 3, and then add on to that the area from 3 to 4, okay, wherever that is. Okay, if you want to know the heights, for example, if you plug 4 into the equation, 4 minus 3 is 1, so there's going to be 4 comma 1. And similarly, if you plug in -1, -1 minus 3 is -4, so this is going to be -1 comma 4. Okay, so you can just use triangles. Another option would be to recognize that these shapes are actually split up. So for example, this half of the graph is x minus 3, and this half of the graph is -x plus 3. Why? Because absolute value is actually piecewise, where this is the ordinary part of the graph, and this is kind of the negative part of the graph. So if you wanted to, there's 2 ways you could do this problem. You could either A, just find the area of the triangles as we mentioned, or the more mathematical way is to find the integral from -1 to 3 of -x plus 3 dx. And then you could find the integral from 3 to 4 of x minus 3 dx, and then just add all of these together. If you don't want to do that, you can use area of triangles. The reason I look at it this way is if we look at a second example, so let's say I have this integral of absolute value of x squared minus x minus 6 dx, and let's say I'm integrating this from -4 to 7 arbitrarily. Okay, so this one's a little bit more difficult, but if we take a look at this and what this graph looks like, it'll be very helpful to our understanding. So this I can factor into x minus 3, x plus 2, which gives me intercepts at -2 and again at 3. Okay, so normally we would graph the parabola and it would look like this. Okay, not exactly like this, but roughly like that. The issue we're having is it's an absolute value, meaning anything that's negative becomes positive. So the part down below here will actually get flipped up here to keep it positive. The rest of the part of the graph is perfectly fine. Okay, so if you want to think of it, all the negative parts, the parts below the x-axis, just get flipped. So that's what the graph looks like. Okay, now keep in mind, I'm trying to find the area from -4. So let's assume here's -4, all the way up to 7, somewhere out here. Let's just assume there's 7, okay? But I also have to take into account all the area in the middle. So, well, how do we split this up? By the same reasoning as before, everything that is above was not changed. So this is just x squared minus x minus 6. And in fact, so is this. This is just x squared minus x minus 6, okay? However, the middle part of the graph got flipped, so it's negative, that whole thing, x squared minus x minus 6. You can think of it as -x squared plus x plus 6. So now how do we integrate it? Well, this first part is just going to be the integral from -4 to -2 of the ordinary graph, so the x squared minus x minus 6 dx. The middle part, however, is the flipped over version. So that's going to be the integral from negative 2 to 3 of negative x squared plus x plus 6 dx. Okay, and then the last part, right here, this last region is going to be the integral from 3 to 7 of the regular graph, not flipped over. Well, and then once you do that, you can just calculate it by adding them up, and you'll get some sort of answer. Okay, so for absolute value, it's very valuable to look at it graphically.